Yeah, actually, last class also I gave my mail ID. Once again, I'm giving. So, if you want any specific topics to be discussed, then you can just email to this mail ID. Okay, uh, with subject like this, something like this. NPTEL get topics. With this subject, you can mail any topic you want. So then that we will cover in the next one, or maybe next session like that. So this is my lady. Yeah, with that subject you can send so that I can filter out from that and I can see. So what about are you guys targeting for GATE this year only? We are in which year? Fourth year. This is my second class of phase two. Actually, last week I did not take, but before that, I think 23rd I took the class. So before last week I took. Last week I did not take the class, and this is the second class of phase two. And once again, mostly I will discuss signals and systems. Uh, phase two on third. Actually, phase two started in November 21st. My class was 23rd, I guess, 23rd November. Then I think then 30th November, another class, but I did not take in 30th November. Then today is my class. And Wednesdays only 6 to 7, same old slot and same old link. Actually, recording I have shared with NPTEL, like we were instructed not to upload in YouTube. You can ask from NPTEL. I have shared the recording. Okay. You were not actually there was some problem. The link actually the meeting link was misplaced. Like something else was kept at meeting link. I think after 15-20 minutes the problem was resolved. Yes, yes. Okay, yeah, yeah. That's what there was some problem in the NPTEL Gate portal. The meeting link, Google Meets link, something else was kept. That's why many could not join. After I think 20 minutes, around 6:20, the problem was resolved. After that, I took the class. Fine, and I can teach topics from signals, digital electronics, even from random variables, random process, communications, and network engineering. So you can ask some topics if you have any specific topic. Just you can mail to that, we can discuss. Because I'm taking some questions from the previous year one only, previous year question papers only. I'm trying to solve. But if you have any particular requirement, you can ask me. Okay. What is PYQ? What is that? Take PYQ from random variable. What is PYQ? Oh, okay, okay, okay. Fine, fine. I will do that. I will do that. Yeah. So, good evening, everyone. So, this is our second class of phase two gate questions. So, as I indicated in the website, so now we will discuss some questions from signals and systems. I'm not sure whether these were discussed by anybody else, I'm not sure, because earlier we were assigned particular questions, but now I am taking from the previous one, so I'm not sure whether these were explained or not. Anyway, we will see this. So this question was given in GATE 2021 ECE for 1 mark. The question is an autocorrelation. So the autocorrelation function Rx of t of a wide sense stationary random process x of t is shown in the figure. So the autocorrelation function is given. So the average power of x of t they're asking. So you know, right, what is correlation? So correlation gives the measure of similarity between any two signals. Yeah, sorry. Correlation gives the measure of similarity, okay, between any two signals. So autocorrelation means, suppose if we have a signal and maybe if we are shifting that signal, and if we are trying to find out the similarity between correlation between those two same signal, then it is called autocorrelation. Suppose if we try to find out correlation between two signals, then it is called cross correlation. Okay, now this question is an autocorrelation. I think you know what is autocorrelation, so the definition I am just giving here. So autocorrelation of some signal, let us say x of t, that is represented with Rx of tau. This is given by x of tau convolved with x of minus tau. Okay, x of tau convolved with x of minus tau. Suppose if it is an energy signal, so you know you have like two types of signals, energy signal as well as power signal. If it is an energy signal, the autocorrelation is given by, so the convolution, right, we know how to write the convolution, but the convolution of x of t and x of minus t. So that's what little bit that changes. So this is from, I think you know this definition, minus infinity to plus infinity, x of t, x of t minus tau dt. So little bit mean you need to apply the convolution only, but instead of t you need to apply tau here. Generally convolution, how we study x of t convolved with h of t we write, but here x of tau convolved with x of minus tau, that minus sign also you need to take care. And also this can be written as something like this also, instead of this also you can replace, instead of t you can replace t plus tau, so x of t plus tau to x of t dt, both are same valid only. Okay, this is autocorrelation of a uh, energy signal. And autocorrelation of a power signal, you know everything is same for a power signal. So the autocorrelation, so you know, right, 1 by 2t will come. Power signal means we will average over some period, right? So limit t tends to infinity, 1 by 2t. So you know the power and energy definitions in the same way, minus t to tt. So one period we are taking minus t to t. So averaging over that one, 1 by 2t, and x of t and x of t minus tau dt. So this is autocorrelation of energy signal. This is autocorrelation of power signal. Now what will happen? Suppose if in this, if I take Rx of 0, that means autocorrelate, let's say energy signal only you take. For that, if autocorrelation, if you calculate at tau equal to 0, So what will happen? That is nothing but Rx of 0. On the definition, you replace tau equal to 0, it will become minus infinity to plus infinity. If it a complex signal, then we will write moderate x of t whole square dt. What is this? This is nothing but energy, right? Energy of the signal, right? This is nothing but energy of the signal. Similarly, for a power signal, autocorrelation calculated at the origin gives the power of the signal. Okay, so autocorrelation value calculated at the origin gives energy of the signal or power of the signal depending on whether it is energy signal or power signal. Now that by definition we have seen what is autocorrelation. So autocorrelation is x of tau convolved with x of minus tau. So if you see one of the properties, autocorrelation is even function of t, even function of tau. If you see Rx of minus tau equal to Rx of tau. So if we interchange x of t and x of minus t, since convolution is commutative, so it will not say change. So autocorrelation is even function of t. And as I said, autocorrelation function calculated at the origin gives the energy or the power of the signal. This is another property. And one more property is autocorrelation will have maximum value at 0. Max value of autocorrelation function at 0, at tau equal to 0. So this is one of the important property. This will be helpful while solving problems. So that means if you see Rx of tau, anywhere you calculate Rx of tau, this should be always less than or equal to Rx of 0. Okay, that means it should have maximum value at tau equal to 0 at the origin. The autocorrelation can be something like this, or it can be something like this, but it cannot be something like this, let us say. Okay, so sometimes based on this you can, it's useful, this property maximum value at the origin. And if you take the Fourier transform of autocorrelation function, if you apply Fourier transform of this, then that is called energy spectral density or power spectral density. This you know, I guess. So if we calculate the Fourier transform of autocorrelation function, then that is called energy spectral density or power spectral density, depending on whether it is energy signal or power signal. This is another important property which will be useful in solving many problems. Especially these will be useful in communications, like interrelated signals, this one, and communications, analog communications especially, and random variables, random process. There are also these topics you may encounter. Okay. And one more thing is for an LTI system, let us say for an LTI system, this I think you will see in communications. So let us say it is an LTI system, h of t, and input is x of t, and output is y of t. And their corresponding Fourier transforms are, let us say, x of omega, and its Fourier transform is h of omega, and its Fourier transform is y of omega. Now, you know, from this we know, right, what is the output? Y of t is convolution of x of t and h of t, but in a Fourier domain, so x of omega into h of omega. Now if we take square on both sides, let us see, if it is complex quantity, the real quantity directly square we will write. If it is a complex one, then how we will write? Like this, right? Mod square. Then it is x of omega square into h of omega square. Okay. So this is nothing but the energy or power spectral density of the output signal, and this is mod h of omega square, and this is nothing but energy or power spectral density of input signal. Okay, this is very very important in communications while solving problems. So what is this? From this we can say spectral density output spectral density equal to input spectral density input spectral density. Please excuse me for my handwriting. My handwriting is like this only. If you cannot understand, you can ask me. Okay, into mod h of omega square. This is very very important while solving some of the problems. Is this clear? This is about correlation. I'm not talking about cross correlation, just autocorrelation I'm talking about. And this is about some of the properties and the definitions of autocorrelation. Is this okay? If you have any doubts, you can ask me. Otherwise, we will solve that problem. So you can feel free to unmute yourself, and you can sometimes respond, and you can ask doubts. You can use chat also. Sometimes you can feel free to unmute. Am I audible? Okay. Any doubts from this? Then we will go to the problem. So the problem given is, see, the autocorrelation function Rx of tau is given of a wide sense stationary random process. Actually, in random process, you will study, right? What is strict sense stationary? What is stationary random process? Wide sense stationary. This is called WSS. Wide sense stationary random process means it's autocorrelation function for a random process, let us say x of t. If it is mean is constant for a random process, this is signal, but for a random process, if mean is constant and autocorrelation function is independent of time, independent of time, then it is called a wide sense stationary random process. Okay, so here so for a wide sense stationary random process, autocorrelation is given Rx of tau. Then the what is the average power of this, you're asking. So just now we have seen the definition, we have seen, right? Somewhere here, yes, this is the average power. This is the autocorrelation function of a power signal, right? Autocorrelation power function of a power signal. In that, if I replace tau equal to 0, then what you're getting, that is nothing but average power, right? So from this, if you see, if you replace tau equal to 0, then what you're getting, tau equal to 0, limit t tends to infinity, 1 by 2t minus t to 2t x of t whole square. What is this definition? You know, this is nothing but the power of the signal, right? That means autocorrelation function at the origin is nothing but the power. So by from that property, it is the autocorrelation function from the at the origin. What is the value? The value is 2, right? So the answer for this 2. Is that okay? Rx of 0 we want. Okay, average power is nothing but Rx of 0. If it is energy signal, and energy equal to Rx of 0. Is that okay? Fine, we will move on to the next question. You feel the question was already covered? What question I taught? Already covered. Okay, fine. We will see another question. This is the question. This was given in GATE 2021 for 2 marks. So maybe some question we'll try to solve. Yeah, that is easy one. Let us say this one. So you just read out the question and we will do some kind of interactive way. You let me know how to approach this. Okay. This is from GATE 2021. The question is consider the signals x of n is given and y of n, where u of n is a unit step sequence and x e of j omega, y e of j omega be the discrete Fourier transform of x of n and y of n respectively, the value of the integral. How to solve this? Can somebody tell me? You just have a look at the question for one more time and you can tell me how to solve this. So since these are discrete signals and that's why they have given the discrete time Fourier transform. For x of n it is x of e power j omega, and for y of n the dtft is y of e power j omega, right? So how to solve this? Can somebody give me a hint? Any hint? So whatever integral they have asked, that kind of relation property have you seen in Fourier transforms or DTFT or Fourier transform? No? So fine. Uh, I think you know the Parseval's and Planck's relation, right? Right? What is Parseval's relation? Parseval's theorem. Somebody can tell me. X of n is x of n and x of e power j omega are the Fourier transform pairs. Then this you know, right? Sigma n equal to minus infinity to plus infinity mod x of n square equal to 1 by 2 pi integral 0 to 2 pi for a dtft. The same relation can be valid for continuous time Fourier transform also. E power j omega square d omega. This relation you know, right? So here, if it is real quantity or what I imaginary quantity, how we can write this? This x of n mod x of n square is nothing but x of n into x of n complex conjugate, right? Similarly, this mod x of e power j omega, this is nothing but x of e power j omega into x of e power j omega complex conjugate, right? Here Parseval's relation is for the same signal. So instead of that, like autocorrelation, cross correlation, instead of that, if you apply this one between two signals x of n and y of n, then that is nothing but Planck relation. Okay, so what is that relation? So if x of n Fourier transform is x of e power j omega, y of n Fourier transform is y of e power j omega, then we can write sigma n equal to minus infinity to plus infinity x of n into y of n complex conjugate equal to sorry, since it's continuous in frequency domain, right? So 1 by 2 pi integral 0 to 2 pi x of e power j omega into y of e power j omega into d omega, right? This is the relation that we know. Now, if you see in the problem, it is something like this, right? This one, what they're asking is something like this, but exactly not like that. But y of e power minus j omega is there. Y of e power minus j omega is there. Let us see. Actually, that is same as y of e power j omega complex conjugate only. Let us see. So that's why I wrote this relation means what they are asking is somewhat similar to this, right? Now you know DTFT formula, you know, right? X of e power j omega. What is the formula? DTFT is what? Sigma n equal to minus infinity to plus infinity x of n e power minus j omega n, right? This is DTFT. Now if I take complex conjugate of this, both sides, if I take complex conjugate, then what will happen? Minus infinity to infinity x of n e power minus j omega n, this one. So x of n complex conjugate, whole one complex conjugate you will get. But for a real signal, let us say, so I think in the problem it is given real signal, right? X of n and y of n, real signal they have given, right? If you see, y of n is what? 2 power minus n plus 2 u of n plus 1, and x of n is 2 power minus n u of minus n minus 2. So from the problem, both x of n and y of n are real signals. So for a real signal, now total what we get, if you take complex conjugate, total you need to take, right? Complex conjugate of this. Okay. Now this is equal to sigma x of n complex conjugate into e power minus j omega n complex conjugate. Since it is a real signal, x of n is real signal, so this is nothing but x of n complex conjugate is nothing but x of n only. And this what? E power minus j omega n complex conjugate, you know, e power plus j omega n, minus j omega becomes plus j omega. Now is the same as x of e power minus j omega, right? Right? So I can write this e power j omega as something like this. I can write e power minus j of minus omega into n. That means this is nothing but this only, right? X of e power minus j omega, right? That means for a real signal, for real signal x of n, okay, x of e power j omega complex conjugate is nothing but x of e power minus j omega. This property we can apply for a real signal. Now in Planck's relation, whatever we have seen here, now since it is a real signal, y of n is a real signal, can we, instead of this place, can we write y of e power minus j omega? We can write, right? Y of complex conjugate equal to y of e power minus j omega. That means the right side quantity is same as whatever was asked in the question, right? 1 by 2 pi integral 0 to 2 pi, that one, right? The right side whatever they have asked. All right. That means what we want, this is nothing but what we want now, sigma n equal to minus infinity to plus infinity x of n y of n complex conjugate. This is what we want to calculate, right? From this. Yeah, from this. This is what we want to calculate. Okay, fine. Now, what is our x of n? 2 power n minus 1 u of minus n plus 2. So, yeah, our x of n is what? X of n is, they have given 2 power n minus 1 into u of minus n plus 2, and y of n is 2 power minus n plus 2 into u of n plus 1. Okay, so what we want, sigma n equal to minus infinity to plus infinity x of n y of n complex conjugate means same as y of n, since it is a real signal, right? It's real. Y of n complex conjugate is nothing but y of n only. Now what are the limits? Now the limits will change to when it is when x of n non-zero, when the inside quantity when u of n, x of n is 2 power n minus 1 into u of minus n plus 2. That means whatever there inside, if it is greater than or equal to 0, then only it is non-zero, right? That means for n less than or equal to 2, the first one exists, I mean non-zero. And whatever the second one, this is for n plus 1 greater than or equal to 0. That means n greater than or equal to minus 1. So the limits now will become n greater than minus 1. That means greater than or equal to minus 1 to upper limit is 2. N equal to minus 1 to 2. So 2 power n minus 1. U of m value is 1 into this one, 2 power minus n plus 2. This is 1. So what you got is sigma n equal to minus 1 to 2. 2 power n minus 1, 2 power minus n plus 2, it will become 2 power 1, right? It is 2 power 1. Now 2 power 1 means 2 only, right? Now n equal to minus 1, 0, 2, 3. Sorry, 1, 2. So that is 2 plus 2 plus 2 plus 2. So this is equal to 8. 8 is the answer. Have you understood? So anybody is having any doubts, you can ask me from this. So basically, two properties we applied here. By seeing the expression what they have asked in the question, this is similar to the Planck's relation that we should know. But similar to that, but there is no complex conjugate here. At y they have given e power y of e power minus j omega, that we don't know. But since the signals are real signals, so this property we can use. Both the signals are real signals, so the property we can use is this one, x of e power, this somewhere we have seen that, yes. For real signals, x of e power j omega complex conjugate is nothing but x of e power minus j omega. These two properties you can use to get the solution. Can we proceed for the next question? Fine, thank you. The next question that we see is, yeah. So which one of the following pole zero plots correspond to the transfer function of an LTI system characterized by the input output difference equation given below? So some we have some LTI system. Okay. So input is x of n. It's a discrete one, and output is y of n. The input output is characterized by this. So what they are asking is, so like this four pole zero plots are given. They are asking which one is the pole zero plot of this one. Okay, na? Of the particular transfer function. First, we need to find out the transfer function. If you see here, the unit circle and all they have given, right? That means it's z plane, right? Real part, imaginary part, and unit circle they have given, right? It's z plane, right? From the options. So better we do in the z domain, right? So discrete one we do in the z domain. Generally, pole zero means either Laplace or z. So since it's a discrete one, we need to do in z domain. So we need to find out the transfer function first. What is transfer function? I think you know, right? So h of z is the transfer function. That is nothing but z transform of output, that is response by z transform of input, that is excitation. So this is nothing but the transfer function of this system, LTI system. Fine. Now what for this, how we will find out that one? We will take the Fourier transform of this. They have given in time domain. So discrete time domain they have given. We will take the Fourier transform of this. Now first what you do, you just expand this. It's looking like some summation, but if you expand, it will become very simpler one. So I'm expanding this. So y of n equal to, now k equal to 0. K equal to 0 means minus 1 power 0 into x of n, plus k equal to 1 is minus 1 power 1 into x of n minus 1, plus k equal to 2 is minus 1 power 2 into x of n minus 2, plus k equal to 3 minus 1 cube into x of n minus. So this will become y of n equal to, so x of n minus x of n minus 1 plus x of n minus 2 minus x of n minus 3 is the input output relation after expanding. Now what to do? Now we need to find out the transfer function. Now for this both sides you can take the Fourier transform. You take apply DTFT on both the sides. So discrete time Fourier transform on both the sides. Okay. Let us say discrete time, sorry, not DTFT, jet transform we will take. I was telling that we will solve this in jet transform. So let us say y of n for a jet transform is y of z, and x of n jet transform, first y of n equal to other side, right side, x of n jet transform is x of z, and minus x of n minus 1. This property we know, right? So x of n minus n naught, time shifting property of jet transform, that we know. Z power minus n naught into x of z, right? Okay. If x of n is having z transform x of z, then time shifted version of x of n is what? Z transform z power minus n naught into x of z. This we know. So the same way, what will happen to this? The z transform is z power minus 1, right? Here if it is minus n naught is there, same z power minus 1 into x of z, and the next one is z power minus 2 into x of z, and z power minus 3 into x of z. Now we need to find out the transfer function. You take x of z common and bring this side. So what you get is 1 minus z inverse plus z power minus 2 minus z power minus 3, right? This is nothing but our h of z transfer function, right? Phi of z by x of z. Now they are asking the pole zero plots. That means for this transfer function, we need to find out the poles and zeros. Just numerator and denominator, just multiplying with z power 3. So what you get is z cube minus z square plus z minus 1 by z cube. So denominator make equal to 0 poles and numerator made equal to 0 zeros. So first I will find out the zeros. For zeros, what we need to do? The values of z where the numerator will become 0, right? This you made equal to 0. This is some kind of simplification only. So z square you take common from first two terms. So z minus 1. And from the second term 1 you take common. So z minus 1 equal to 0. Again z minus 1 you take common. What we get is z square plus 1 equal to 0. That means z minus 1 is 0 means z equal to 1 is 1 0, and z square plus 1 equal to 0 means z equal to plus or minus j. This is another 0. So these are the zeros. Okay. And what about poles? For poles, denominator made equal to 0, right? So z cube equal to 0. This is, that means z equal to order 3, 0 comma 0 comma 0, or you can say z equal to 0, a pole of order 3, right? Z cube is there of order 3. So from this, which one will be the answer? So the first one is, they said that origin third order pole, and what are the zeros for us? 1 minus 1, 1 minus j and plus j. This is correct only, right? And second option is wrong. Sorry, that is first option. Second option is also, second option is wrong, because did we do correctly or any mistake we did? No, right? So just I'm drawing. If it is real part of z, if it is imaginary part of z, and this is unit circle, let us say. So three poles are at the origin. So 1, 2, 3, three poles of order 3. And z equal to 1 is 1 0. Z equal to 1, this one. This is unit circle, right? And plus or minus j on imaginary axis. And here 1 0. And here 1 0. So this is the answer. I think first one only is the answer. Second one is wrong. Third one is wrong. Fourth one also wrong. First one is the answer. Is that okay? Any doubts for anyone? Okay, fine. Banti and Vaishnavi. Who else are there? Shall we move on to the next question? Okay, okay, thank you. Huh. This question was given in GATE 2020 ECE for 2 marks. The question reads as follows. A system with transfer function is given for a greater than 0 is subjected to an input. The steady state output of the system is this one. The value of a is. Okay, so this, how to solve this, can somebody tell me? I think earlier some concept related to this, I think a couple of times I discussed this kind of things. Can somebody tell me? Here the input is sinusoidal, you can see. Obviously output also sinusoidal you will get. So this kind of problems earlier we have seen. Just in S domain they have given, that's it. In Fourier domain we have seen. Fine, let us say you have a system with h of t, okay, as h of t is the impulse response, and h of omega is the transfer function, and you are giving for this some a cos omega naught t plus theta, some sinusoidal signal you are giving input. Then I said the output also sinusoidal signal, but there will be an increase or scaling in the amplitude. Now at this omega naught, at the input frequency, you find out the what is the magnitude and phase of the transfer function. Okay, at the input frequency omega naught, you find out what is the magnitude and phase of the transfer function. Now the output is same as input, but the amplitude is multiplied by the magnitude. Okay, and the phase will be added. So omega naught t plus theta plus extra, let us say this I am saying phi, extra phase will be added. Okay, especially for an LTI system, if we give a sinusoidal or complex sinusoidal signal as input, then output also the same, but there will be an amplification in the magnitude amplitude. Let us say this, you say k gain at that frequency, input frequency. So amplitude is multiplied by k and phase is added. This principle we can use here, since what is the input they have given. So g of s they have given. So if we keep s equal to j omega, then what we get is g of j omega. Yes. Now input they have given phi cos 3t. Output they have given something they have given. Now we can apply the same principle, right? So by which we can calculate, right? Now let us see for this phi cos 3t, what is the output? Let us see. Now g of s is what? G of j omega I'm finding out now. G of j omega, that is g of s at s equal to j omega is what? 1, instead of s you can replace j omega, right? That you know, right? Laplace transform calculated on imaginary axis. That is nothing but the Fourier transform, right? So continuous time Fourier transform. So if s equal to j omega, if you replace, what is the transfer function? 1 by j omega plus 1 and j omega plus a, sorry, j omega plus a. Now what is the input? Our input is what? uh, 5 cos 3t, right? 5 cos 3t, that means omega naught is how much here? Omega naught equal to 3, right? Now what is that? G of j3 will become s equal to j omega, omega is 3, this will become 1 by 3j plus 1 into 3j plus a. Now, what is the magnitude of this? Magnitude and phase we need to find out, right? What is the magnitude? Magnitude nothing but k. We said, right? This one k. Magnitude is what? 1 by square root of 9 plus 1 and square root of 9 plus a square. So magnitude is 1 by root 10 into 9 plus a square. This is the magnitude. What about the phase? The phase phi is denominator is there, right? Tan inverse we can write minus denominator. So when it go to numerator, it will become minus. So tan inverse of 3 by 1 minus tan inverse of 3 by 8. Okay. Now from this, what is the output now? Since input is what? 5 cos 3t, output should be 5k cos 3t plus 5, right? It is multiplied, magnitude is multiplied, amplitude multiplied with the magnitude k, and phase will be added. So 5k cos 3t plus 5. But what is this now? 5k is what? Root 10 into root 9 plus a square cos 3t plus 5 is something. Just I'm writing 5. But in the question, what is the output they have given? Steady state response. Output, what they have given in the question? 1 by root 10 into cos 3t minus something. So actually, this is what we got. But in the question, what they have given? Y of t 1 by root 10 into cos 3t minus 1.892. Phase 1.892. Okay, this is what they have given in the question. This is what we have calculated, right? So that means both we can both are same, right? Both are same, we can equate. Now first I will, you have to equate magnitudes, and also you have to equate the phases, whatever phase is there. So magnitudes, if I equate 5 by root 10 into root 9 plus a square equal to 1 by root 10, right? Magnitudes if I equate, then what we get? 5 by root 10 we can cancel, so 5 equal to root 9 plus a square. So 25 minus 16 equal to, sorry, minus 9 equal to a square. So a square equal to 16 implies a equal to plus or minus 4. Okay, and we don't know whether a is plus 4 and minus 4. But another equation is there. So if we equate phase, so tan phase is there, minus tan inverse 3 minus tan inverse 3 by a. Here also you can equate, from here also you can get phase. Sorry, a you can get. But in the question they have given a is greater than 0. Clearly they have given a is greater than 0, right? So no need to solve the other equation. No need to solve the phase 1 here. So already we got a equal to plus or minus 4 we got. In the question they have clearly given a greater than 0. So our a is 4. We can directly write. Okay. The same principle we have used for like an LTI system. If you give sinusoid as input for any system, the output will be sinusoid only. Okay, but the magnitude changes and phase will be added. So but it is given in Laplace domain, but we know Fourier transform calculated at s equal to j omega, real axis, sorry, imaginary axis. This is a sigma axis, this is j omega axis. Fourier transform Laplace transform, sorry, Laplace transform calculated on j omega axis is nothing but continuous time Fourier transform. This one we have used here. Is it okay? Any doubts from anyone? Think we have 3 minutes more. Shall we? We cannot complete another question in 3 minutes. So anyway, next class also there. We will stop here. You can just feel free to unmute your mic and ask any questions, any queries, any suggestions if you want. And my class will be like phase one only. Wednesday 6 to 7. Same link. So whatever the Google Meet link that we were using earlier, the same link only. 6 to 7. But I'm not sure. I cannot upload the recorded one in YouTube. But just giving them to NPTEL, you can just ask from them. Maybe they may upload in YouTube and give the URLs. So somebody has asked for the next class, they want questions from random variables and random process, right? Previous year's questions from random variables and random process, right? Okay. Anything else? Actually, incidentally, this question, whatever we solved here, autocorrelation, this one actually from, can say random variables only, random process, sorry, that we use in signals and communications. Any other things? Anybody wants any other things? Can you take networks? Okay, fine. Uh, Networks, which topics you want? You want me to take previous questions or questions from network theorems or transient analysis or steady state analysis or phasors? Previous questions. So what you want me to do, just like I'm asking from your side, can I go back from 2021 to back signal just like that I started? Earlier I was assigned some questions I was solving. Okay, questions from cross correlation. Let me write this topic. Mm, So previous questions from random variables, random process, then networks and cross correlation. Anything else? 2022 EC question 54. Okay. Okay. That's it, right? Maybe I think some of them we will cover in the next class. Question 54. Fine. So as I said, you can mail me with that subject. I think somewhere here. Once again. If you want any topics, this is my mail ID. What I do, I start with 2022 gate and I'll go back. Okay, and question 48 also. from 2020 to GATE. Okay. Any other things? If you want, you can just mail me. Yeah. Thank you all. Thank you very much, everyone, for your patient listening. Thank you. You can join the other session.